So before we're able to start using a compass, we need to recognize the parts of a compass. So this right here is a good start to your standard compass. We have this one here, which looks very similar. And to be quite honest, most of your compasses are going to look very similar, at least the ones that are going to be designed for use in orienteering and navigation. This one here on the right-hand side is the one that I've loaned you. And you'll take a look at a few of these manufacturers. You have Sunto right here. You have Silva. It's kind of hard to see because it's embossed on there, but this one right here, if I put something dark on the back side here, maybe you can see that. Also Sunto. Those are a couple really prominent companies that work with compasses, and those are going to be some better ones. If I take a look here and slide in a different one, this one right here, if I take a look, I can see some differences here. This one seems to be lacking a lot of the parts that this one has, some of the lines and everything else. This one's made by Coleman. Coleman makes a lot of really affordable, durable camping gear that would probably be considered, medium to low end in terms of your fanciness and the cost. But most of their stuff is just fine, and you could use this one just fine for navigation. But the lack of all the different pieces and parts on the inside is going to make this one certainly inferior to one of these here. In addition, the dial, as we see right here, this dial spins very easily. You don't want an easily spinnable dial. You want one that has a little bit of resistance so it doesn't accidentally shift on you. You'll also notice that on the inside, I don't have an arrow like I have here. You can see an arrow right here pointing up to this corner here. They've replaced that with just a couple of little lines here. So again, nothing wrong with this one. This one could be used just fine, but it's going to be inferior to one of these here. Now, these are pretty basic, but if you want, you can always kind of take a step up, and you could use something that has a mirrored surface to it. So what we have here is we have the same generic shape, but we also have this mirror that's going to be included. Now this mirror is going to serve a purpose when it comes to trying to find the the direction and the bearing to a location. So we'll talk about why the mirror, what the mirror's purpose is when we get to that part. Now when it comes to using a compass, I'm going to use the one that you have as an example here. All these compasses have the same parts to them that we're going to look at, and then we'll take a look at how to use it after that. So first, this whole thing comes on a base plate. So this big piece of plastic right here, we just refer to that as our base plate. This arrow pointing, this big prominent arrow that's part of the base plate, that is the direction of travel. I have two little arrows here for my direction of travel. I have one big arrow here for my direction of travel. And even our Coleman one has an arrow up here pointing, again, our direction of travel. So that is quite literally where you are going to walk. I always say this should point away from your chest. When you hold this in front of you, this should point right away from your chest. That's where you're going to be walking. That's where you're going to be moving. Line of travel. In addition, on the inside, we got some markings along here that are useful when you use these things with a compass. With a map. But when we look over here, this dial and all the parts that go with it, there's a lot of stuff going on in here. So let's take a look at them. Number one, you have this red and black metallic piece that is our compass needle. We call that the needle. Now, your compass needle could come in an assortment of colors. This one is red and black. This one is red and white. This one here, red and black, red and white. And what's the common color for all of these? The color red. Red is going to represent our north needle. Now, every needle has an opposite side to it that would be considered south, but the red is always going to be that north needle. This needle is free to spin around. It is balanced perfectly on a little pin, and it is a tiny little magnet. And this tiny little magnet is attracted to a ginormous magnet that is known as the Earth. this red needle will always point to the same northerly spot on the planet Earth. Now we'll talk about where exactly that is, but for right now that doesn't matter. This points to the same spot on Earth no matter what. So I can use it as my reference. A reference is anything we use to decide where we are. The Earth can be a reference, North Pole can be a reference, your house can be a reference. I'm 2 miles from my house, so this is going to be our reference. In addition, we have our dial. Our dial has grooves on the outside so I can get a good grip with my hand, and this dial has numbers going all the way around. N is going to be the very first value. You'll notice there isn't a number there. That's going to be 0, 20, 40, 60, all the way around until we get to 320, 340, 360. So I have 360 degrees in a circle. I have 360 degrees on my dial. This dial is able to spin. So as I slowly spin the dial, notice that the compass needle stays where it is, still pointing north. Notice you'll see right here that little white line that's lined up with my direction of travel. That white line stays put. As you see the 280, the 300 go past that line, 320, that line stays put. So the dial and the numbers on the dial, they spin around. Notice on the inside of this dial, it spins as well. First thing I notice on the inside of my dial, I have it pointing straight to the top of the screen right now, is this red arrow. This is my orienteering arrow. Some old school people might refer to this as a lubber line. We're going to call that the orienteering arrow. The back side of the orienteering arrow is black, and it corresponds with the red and the black needle that I have on my compass. So that orienteering arrow always points to the N. In all the other examples I have, the arrow points to the N. This is where our Coleman compass was a little bit lacking. It didn't have that arrow. Notice next to the arrow I've got these black lines. As I spin the dial, the arrow goes around with it pointing to the big N. Notice the arrows go with them as well, or the lines. Use your words properly. The lines are parallel with my arrow. Those lines spin. Those are my orienteering lines that go along with my orienteering arrow. And they're all part of the dial, and they all spin around together. All right, so that's right there, though it represents everything that we have on our compass that we're going to need to properly use the compass. So a couple of the things before we actually start to use our compass. Number one, this compass needs to be held level. There are certain compasses where you don't have to hold them level because of the way they're designed. These would be compasses that you would use on perhaps a boat or an airplane, maybe even a car. Usually they look kind of like a ball or a sphere, and they always stay level for you. Well, this is not that kind. Okay, so what we're going to do is we're going to make sure we hold it level. That way, as I slowly spin my compass around, that way my compass needle, the red-black compass needle, stays aligned with the north-south direction. So I need to make sure I hold it level. If I kind of tilt at an angle and try and spin, you can probably see there that red needle doesn't spin because I haven't given it the ability to spin. So it's got to stay level. So when I place this in my hand, I'm going to make sure that I pivot my hand so that this stays level. In addition, I need to make sure that my compass stays far away from any bits of metal. Now, the physics teacher in me would like to say that only certain types of metal are going to have an effect on our compass. If you're out in the bush and you don't know what kind of metals you are dealing with, then it's just a good idea to keep all metal away. But to be very, very simple, basically anything that has iron or steel in it, which is a lot of our metallic products, and anything that might have nickel. So right here, this is just a generic clipboard. And I can bring in my clipboard and notice, as soon as I bring my clipboard in, notice what happens to my compass needle. It's moving. Take the clipboard away and it goes back. So just that little bit of metal right there is enough to cause this thing to twist in the wrong direction. There have been accounts in northern Michigan where there's a lot of iron in the ground. Up in western Upper Peninsula, where your compass might get affected by large amounts of iron in the ground, but the likelihood of you coming across something like that while requiring the use of a compass is probably going to be pretty slim, so I don't think there's much to worry about there. Now when it comes to any metal that is near our compass, you also need to be concerned with any metal that maybe isn't visible. For example, on the table that I have here, you'll be able to see that I can affect the needle because the metal and the effects of the metal go through other objects. Not to go into a big physics lesson, but it's kind of like gravity. When your feet are on the ground, gravity is holding you to the earth. When you jump up into the air, gravity still has a hold of you. If you were to put some padding, some wood, something underneath your feet, you still have gravity pulling on you. That's the way the metal works with our compass needle. And not only that, my pen, my little clicker pen, has an iron spring in the tip. And look at what I can do just with the tip of my pen. I can move this compass needle around just because of that teeny tiny little bit of metal that's in there in the form of a spring. So your compass, especially a good compass, is going to be very, very sensitive to the metal that's in the vicinity, any metal at all. So here I have that same compass. You can see the red needle is pointing towards the bottom of our screen. What I'm going to do is I'm just going to set this down on my tabletop, and you'll notice all of a sudden that the arrow, the needle, I should say, is not pointing the bottom of our screen anymore. Now it's pointing off back to the left. If I simply move my compass over here, I notice that the arrow, the needle moves again. Why is that? Because right under here, going across my folding table, is a strip of steel that gives this table support because it's made out of plastic. So even metal underneath something might have an effect on my needle. So now when you're out in the wilderness, you're going to have this in your hand, so it's probably not going to be a concern, but it is something to be mindful of. So we keep this level so that the needle can spin. We also make sure we keep this away from anything that is metallic. If you're not sure what type of metal something is, then you keep your compass away so that you know your compass is going to function properly. You may have also noticed not just other pieces of metal, but also two compass needles can affect each other. So we've all played with magnets in a science classroom or just in general. When you play with those magnets, you have opposites attract, likes repelling. They attract each other, they push each other away. Well, that's what I have happening right here. I have two magnets that are just interacting with each other. So even little compasses from, if I have two compasses together, are enough to cause my needles to be deflected in a way that I don't want. So I'm going to make sure that everything is far away when it's time to use my compass. And we do two things with our compass. We can either find the direction or the bearing to a distant object like a tree or a mountain or something on the horizon. And we can also use it to face and therefore walk a particular direction. So option one, I can look at a tree and I can figure out the direction to that tree. It'll be a numeric answer, one direction out of 360 degrees. The other option is someone gives you a direction. For example, if someone says that you need to go at 120 degrees, we're going to use a compass so that we can face 120 degrees. So what we're going to do first is we are going to find the direction to something distant. So I'm going to look up, and when I look out the window, I see that oak tree right there. It's the closest tree to us. I want the direction to that oak tree. So what I'm going to do is I'm going to look down at my compass so that that compass is in my hand. It's easier if I don't use my hand, if I use this tabletop here. And the first thing I need to do is rotate that compass so that it points from me, my chest, to where I want to go. I want to go to that oak tree. So now that I have this pointing the correct way, my red needle is pointing towards north. That's going to happen no matter what. And so now what I'm going to do is I'm going to take my dial and I rotate until eventually the compass needle, that is red, and the orienteering arrow, that is red, I make sure that they are aligned. Some people like to call the red orienteering arrow, they like to call it the shed, because when you look at the arrow, it kind of looks like maybe it's a roof, and so they call that the shed. And so when you're trying to find a direction on your compass, the phrase that some people like to use is you want to put red in the shed. So the red end of your needle goes into the arrow, which we're calling the shed. So you put red in the shed. Once red goes in the shed, I know that this compass is pointing to my destination, the oak tree. I know this is pointing towards north, and I can see that my arrow is right there. There's the angle between north, which I know because of the needle, and where I'm going to go. How do I know where to go? I look at the number at the very top, the number that's next to my direction of travel, the number that's next to that little white slash right there. So it looks like 200, 220, looks like I'm really close to 210 degrees. Now, once I have lined that up and I've got a good number, if I accidentally move this and red is no longer in the shed, that's okay. I still have 210 degrees on my dial. It's why having a dial that has some stiffness to it is preferred. That way this dial doesn't accidentally move. So now if this thing is hanging by a string around my neck, if I have this thing in my pocket, I already have it all ready to go, 210 degrees. So I don't have to always have this thing lined up perfectly, only when it's time to do my hiking. So that is how we find the direction to or the direction of the bearing to a distant object. So if I want to walk to that tree, I know from here I got to go 210 degrees. The second thing that we use a compass for is if we are given a bearing, how can we face that bearing and then walk that bearing? So I still have my 210 from the previous example. So let's say that someone tells me the number I used before was 120. They said, you got to go 120 degrees, and that's where the buried treasure is going to be. Well, great, let's go get some buried treasure. So what I'm going to do, I know that this arrow is going to point where I'm going to walk, and I know that if I get red in the shed, I'll get the right or the correct amount of the correct angle between north and where I need to go. So what I'm going to do is I'm going to spin my dial. This arrow is where I want to go. Where do I want to go? I want to go to 120. So I'm going to rotate until 120 is right there. Now, when I get red in the shed, I know that my red destination arrow, my direction of travel, will be aligned with 120 degrees. So now all I have to do is grab my compass and I take the whole thing and I start to rotate it. I don't rotate the dial. If I rotate the dial, I'm going to end up going in a different direction. I want to go 120. So I literally rotate the entire base and the dial itself. Rotate, rotate, rotate until I have red in the shed. Looks like red is in the shed right there. So which way do I have to walk? I have to walk that way, the direction of travel arrow. That's where I have to walk to get to my destination. Red's in the shed. So I can dial in anything on my dial, and all I have to do is hold this in my hand. So I would literally, quite literally, I would hold this in my hand, and I can literally spin my whole body with this compass in my hand until red is in the shed. And again, it's easier to see with a white background in terms of a video, so that's why I have it sitting right here. This would typically be in my left hand because I am right-handed. I would typically hold this in my left hand so I can manipulate everything here with my right. And that's how I use my compass. So what do? We figured out the direction to my oak tree by pointing to the oak tree, spinning it around until we had red in the shed. All right, so jumped around on me there. Okay, something like that. Option number 2 was someone gives me a bearing, and how do I get there? I dial in the bearing. Let's say I want to go 300 degrees, so I dial in right there, 300 to the tip top, and I literally rotate my whole body with my compass until eventually, again, I get red in the shed. Once I got red in the shed, something like that, there we go. I know going that direction is going to be how we get to our destination at 300 degrees. All of your other compasses that are fancier just have different methods to do all the same stuff. What are you doing? You are aligning a metallic magnetic needle with this dial. You're aligning them, and the number at the top tells you which way you're going. Remember, the number is the number that's aligned with the arrow. When in doubt, because there's numbers all the way around here, right? When in doubt, think about it. If you're holding it so that this arrow is pointing away from you, there's only one number on here that is upright, 300. You should never have to read upside down numbers. So if I look at this, shouldn't it be 120 because it's facing me? Nope. It should be 300 because that's aligned with our direction of travel arrow.